In this video, we're going to look at how to solve basic trig equations. In order to do this, we're going to use the algebra that you've seen in the past to solve other types of equations, as well as some understanding and knowledge of the behavior of trig functions. The general process for solving a basic trig equation is the following. First, we're going to find all the solutions in one period of the trig function in the equation. If the trig function is sine or cosine, then we know the period is 2 pi, and so we'll look in the interval 0 to 2 pi. This is within one complete rotation around the unit circle. If the trig function is tangent of x, then we're going to look in the interval 0 to pi, because the period for the tangent function is pi and not 2 pi. Once we have all the solutions in one period, either between 0 and 2 pi or between 0 and pi, we can find all the solutions to the trig equation by adding every multiple of the period to the trig function to those solutions that we have found within the first period. So for sine of x and cosine of x, we're going to add 2k pi to each of these solutions, where k is any integer. This will allow us to add 2 pi, 4 pi, 6 pi, 8 pi, etc., as well as negative multiples of 2 pi, like negative 2 pi, negative 4 pi, negative 6 pi, to those solutions. Since the trig functions are periodic, we know that after we add a multiple of the period to an angle, that the trig function is exactly the same. So if a certain trig function had a certain value at some point, then adding 2 pi to that angle will give us the exact same trig value. With tangent, we do exactly the same thing, except that we add k pi to all of the solutions from step 1 instead of 2k pi, and again, this is because the period for the tangent function is equal to pi. So let's take a look at how to put these steps into action with a few examples. In this example, we're going to find all the solutions to the equation cosine of x equals 1/2. To do this, we're going to use the two-step general strategy that we just discussed. The first step is to find all of the solutions of this equation between 0 and 2 pi, which is the first period of cosine of x. To ensure that we get the full solution set at the end, we do need to make sure that we get every solution of this equation between 0 and 2 pi. And to do this, we can always double check with our unit circle. So if we have our unit circle here, we know that the cosine represents the x-coordinate of the point on this circle. And so what we're looking for here is all points where the x-coordinate is equal to 1/2. So 1/2 would be right around here on the x-axis. And so if we kind of take a vertical line here, we actually see that just as if we didn't know ahead of time, we actually can see here that there are going to be two solutions to this equation. There's going to be two angles between 0 and 2 pi whose cosine equals 1/2. One of the angles is going to be in the first quadrant, and the other is going to be in the fourth quadrant. Now, to actually identify the angles, we go back to our basic knowledge of trigonometry. And we do know in the first quadrant an angle whose cosine is 1/2, and that would be pi over 3. Right, so this is just knowing our basic values of trigonometry, our basic unit circle values. The angle in the fourth quadrant, we can find a number of different ways. We do know that it has a reference angle of pi over 3 in order to have a cosine of 1/2, and so the angle there is going to be 5 pi over 3. So these are our two solutions in 0 to pi. Now to find all solutions, we have to add all multiples of the period of cosine to each of these. And so what we get for a full solution set is the numbers x of the form pi over 3 plus 2k pi, and the numbers of the form 5 pi over 3 plus 2k pi, and here k is any integer. And so this describes all possible solutions of the equation cosine x equals 1/2. Notice that k, being an integer, is allowed to be negative and so we're also subtracting all multiples of 2 pi as well. Let's take a look at another example involving the sine function. In this example, we want to find all the solutions to the equation sine of theta equals negative square root 2 over 2. And again, we're going to follow our general strategy for solving basic trig equations. The first step is to find all the solutions in the intervals 0 to pi. Again, we can use a unit circle to kind of guide us to do this. We know that the sine value is the y-coordinate of our point. And so somewhere down on the negative part of the y-axis is the number negative square root of 2 over 2. And we can see that if we look across here, we see we have two angles with this particular sine value between 0 and 2 pi. And so we're going to have two solutions between 0 and 2 pi to this equation. We also see that those solutions will be in quadrants 3 and 4. And so if we have sine of theta equals negative square root of 2 over 2, because of the square root of 2 over 2 part, we know that these are going to have a reference angle of pi over 4. And so we need to find the angles in quadrants 3 and 4 with a reference angle of pi over 4. And those angles are 5 pi over 4 and 7 pi over 4. Those are the angles in the third and fourth quadrant, respectively. So this is these are coming from just our basic knowledge of trig and their basic values. Now to get all the solutions, we need to add on all multiples of the period of sine of theta to each of these. We know the period for sine theta is 2 pi, so we need to add on all multiples of 2 pi to both of these solutions. So we get a final set of solutions as theta equals 5 pi over 4 plus 2k pi, 7 pi over 4 plus 2k pi, and again, k is any integer, both positive or negative. That'll give all the negative multiples of 2 pi as well. So this is the solution set for the equation sine theta equals negative square root 2 over 2. In this example, we want to find all the solutions to the equation 2 cosine x minus 3 equals negative 5. Before we are able to simply write down the solutions to our equation, we do need to do some algebra to get this in the form trig function equals a number. And so in order to do that, we're going to start with our given function, and we're going to apply the techniques that you've seen for solving equations of different types in the past. And we're going to isolate the trig function on the left-hand side. So to do that here, we're going to add 3 to both sides to get rid of the negative 3 on the left. So we're left with 2 cosine x, and negative 5 plus 3 is negative 2. We're then going to divide both sides by 2, and that leaves the equation cosine x equals negative 1. Now this equation looks like the ones in the previous examples. We want to solve cosine of x equals negative 1. We find the solutions between 0 and 2 pi, and then add multiples of 2 pi onto all of those solutions. If we use a kind of a unit circle here to guide us, as we've done in the past, we're going to look for cosine of x, which is the x-coordinate of our point on the unit circle, and we want to know when is that equal to negative 1. Well, this point over here is the only point on the unit circle with a cosine value of negative 1. So in fact, there's only one solution between 0 and 2 pi for this particular equation, and that is x equals pi. And so this is the only solution. Oftentimes these trig equations will have 2 solutions between 0 to 2 pi, but this particular one only has 1. So that is sometimes something that occurs. So you should be careful with that. So this is our only solution between 0 and 2 pi. And so to find all solutions, we're simply going to add multiples of 2 pi to this solution. And again, k here is any integer. There are, of course, more complicated trig equations than the ones presented here in this video. All of the ones here that we've seen either were already written as a trig function equaling a constant, or like the one here, can easily be written in that form using basic algebra. More advanced trig functions will require more advanced algebraic techniques such as factoring to solve, or it could also involve using trig identities to rewrite certain trig expressions as other trig expressions. Um, Ultimately, though, those complicated equations will all simplify down to having to solve one or more of these basic trig equations. So it's very important that we have a solid understanding of how to solve the relatively straightforward ones here, where we have a single trig function equaling a constant.